Okay, so it should be beyond this point, right? X squared over x plus 3, that makes one singular log on the left-hand side, and then you have log base e over half on the right-hand side, which means you can take these two equations out. You got x squared over x plus 3 equals to half. Multiply both sides by 2 times x plus 3. So left-hand side becomes x 2x squared, right-hand side becomes x plus 3, which means 2x squared minus x minus 3 equals to 0. Right, so this is a full-on quadratic that you're solving. You want to factorize it. 2, 1, 3, 1, like that. 2x minus 3 by x plus 1 equals to 0 using the cross method, giving us, in this case, 2 solutions. All right. What's this final step that I keep yapping on about, right? What are we doing this last step? Does anyone know what I'm talking about? Yes?
I'm talking about it.
Yeah? What's the purpose?
Because logs have like an implied domain.
Yeah, very good. Yep, very good. Okay, so logs have an implied domain. That is very accurate. That is exactly what I was going to say. What is the implied domain for logs? That their argument, this guy here and this guy here, has to be a positive value. So when you're solving a log equation, you need to be thinking, my log says x can't be certain values. What can't x be? Well, in this case, x needs to be greater than 0, right? Because log base e can't accept an x value that is negative. And this one says x needs to be, well, x plus 3 needs to be greater than 0, which means x is greater than negative 3. I mean, which one is more restricting? One says greater than negative 3, the other one says greater than 0. Which one's more restricting? Greater than 0, right? If you just look at negative 3, then that's saying, oh, x can be negative 2. But that's actually not the case because we got a different component saying x has to be greater than 0. And that's important because this log function doesn't exist for the solutions of x that are before 0. Then, now have a look at our solutions. We have 3 over 2 and negative 1. Right? How can you have a solution of negative 1 when negative 1 isn't even a part of the graph, right? This 2 log base e of x, this thing doesn't even exist for the values of x that are before 0, right? Because x has to be greater than 0. So always make sure to go back to check your log restrictions before you give your final answer. So in this case, I would not have negative 1 as my final answer. It would be x equals to 3 over 2 as x is bigger than 0. Always give a reason for why you're rejecting one of the solutions, in this case, that negative 1. I'm rejecting negative 1 because I know x has to be greater than 0. Why? Because that is the restriction that this log function naturally carries. You don't need to say that much. You just need to say as x is bigger than 0. So the examiner knows, right? You've not just forgotten about one of the answers. You know that one of the answers can't be taken, right? Because it doesn't fit the domain. Right? Just always make sure to justify why you're rejecting or kicking out one of the solutions. So always think about that for log functions. Let's go back to the previous ones. The first one here, just as an example, what are the restrictions that this carries? So this one says x needs to be greater than 1, right? Because x minus 1 is greater than 0. X needs to be greater than negative 2. And this last one says x needs to be greater than 4 over 3. So there are 3 conditions from the 3 different logs. Which one is the most restricting condition? Okay? Think about it. One says x has to be greater than 1. The other one says x has to be greater than negative 2. So 1 is definitely more restricting than negative 2. The last one says greater than 4 over 3. So this is the most powerful out of 3 because it narrows it down to the smallest region of values. These two, in the areas that these two exist, this one doesn't, which means that there can't be a solution, right? All 3 need to exist in order for a solution to occur. So you need to be checking, are my values of x, my final answers, greater than 4 over 3? And in this case, they are. Right? X equals to 2, x equals to 3. They're both values that are greater than 4 over 3, therefore they can be accepted. Right? So why when we do this first step, it kind of does give it away in this box here, right? When you solve log expressions, log equations, always make sure that your solutions actually satisfy the domain your initial logs carry. Okay, so you can do the same with the other ones, but like A, B, C, none of them actually have this. None of them actually ask you to reject a solution all the way until D when one of the solutions actually does not fit the domain. Okay, so just make sure to check that. It is so important for logs. because you turn it into a quadratic or linear and then you solve that and you forget all about how you're actually working with logs. There's a really, really good question on this 2019 exam. Right, it was like a log function, and inside it was like a cubic divided by, I can't remember if it was a linear or a quadratic, and that just completely changes the domain of the log. Because when you use log laws, I think that expression reduced down to like log base e of something linear, but it started with a cubic dividing by something else. So anyway, it's really hard to kind of put into words right now, but 2019 exam, I think 2% of students got that question right. It was just purely testing a log function, taking another function as an input, and that other function having a restriction that it has to be bigger than 0. Okay, so it's something that you guys have already learned about. Obviously, in that case, those functions are a little bit more complex. Let's go to D. Have a look at D here. Stuff. We have log base 10 of x altogether squared plus log base 10 of x minus 2 equals to 0. In this case, you should be thinking about the powers again, because you have log base 10 of x altogether raised to the power of 2. Then you have it raised to the power of 1, and then you have a constant. So what are you thinking here? This is yet another hidden quadratic, okay, which means that you will need to use a substitution. This one makes it fairly clear, I want to say. So the substitution that we're making is a equal to log base 10 of x. Okay, so this gives a squared plus a minus 2 equals to 0, which means a plus 2, a minus 1 equals to 0, just by factorizing that quadratic. So this gives us two solutions of a. So what do we say before? A equals to negative 2 and 1. In this case, can a equal to negative 2? Can a equal to negative 2? It actually can. Okay, so don't get confused here. A is not the input, right? I did ask you a couple of times, hoping that someone would say, yeah, you have to reject a as negative 2. Right? You actually don't do that here because a is not the input. A is not the domain. What is A? A is the entire log. The entire log function itself can be a negative value. Okay, so if this was the value that we're talking about and that came out to be negative 2, then you have to reject it. But a isn't x. A is log base 10 of x. So if both are acceptable, what are the answers? So log base 10 of x, right? Since that's equal to a, this is equal to negative 2 or positive 1, which means that x equals 2 from the first one. Log base 10 of x is negative 2. X is 10 to the power of negative 2. Right? This is a value that definitely exists. Or, what's the other one? X equals to 10 to the power of 1. So finally, your solutions are x equals to 10 to the negative 2 is 1 over 10 squared, which is 100. So 1 over 100. Or x equals to 10. These are your two solutions. X1 divided by 100 or just 10. So please do not get tricked by this. Right? These are two different scenarios. That negative 2 is acceptable. In the previous case, it wasn't because they refer to different parts of the log. This negative 2 is the entire log expression. What we had before was just the argument of the log.